Let's look at number 5. Number 5 is 1 over 1 minus x squared raised to the 5 halves dx. Well, this one might look strange because it doesn't have a radical, but just like we did in example 4, we can rewrite that 5 halves power as the square root raised to the 5th, and then it looks exactly like all the other problems that we've been dealing with. So instead of writing it to the 5 halves power, again we can write it as the square root of 1 minus x squared raised to the 5th power dx. Now let's figure out which substitution we need to use. Well, what do we have? We know we have number minus variable, and when it's number minus variable, we use u equals a sine theta. So what is a in this case? Well, a squared is equal to 1, therefore a is equal to 1. What is u squared? Well, u squared is x squared, so we know that u is equal to x. That means that x is equal to 1 sine theta, but I don't really need to write that 1, so we can just say that x is equal to the sine of theta. Now I have to transform this whole entire integral from an integral in x's to an integral in thetas. So I say the indefinite integral of 1 over, well, if I'm getting rid of dx, I need to take the derivative here of x. Well, the derivative of x is going to be, the derivative of the sine is cosine of theta d theta. So here I write cosine theta d theta. Now I have to get rid of that square root of 1 minus x squared. Well, how do I do that? I do that with a triangle. So if x is equal to the sine of theta, making the triangle here, we know that sine is equal to opposite over hypotenuse. There's no denominator, but I know my hypotenuse would then be a 1. And that missing side would be the square root of 1 minus x squared. Which trig function relates with the Pythagorean identity with sine? Well, we know that that's going to be cosine. Looking at the triangle, what is the cosine of theta? Well, the cosine of theta is adjacent, which is the square root of 1 minus x squared, over hypotenuse, but my hypotenuse is 1, so I don't need to write it over 1. But now I know what this square root of 1 minus x squared is. It's equal to the cosine of theta. So I rewrite this as the cosine of theta, and that still gets raised to the 5th power. Now I'm in an integral that's all in thetas. So what do I do here? I reduce. Well, notice that I have 5 cosines in the denominator and 1 in the numerator, so one of them is going to cancel, and I end up with the indefinite integral of 1 over cosine to the 4th theta d theta. Well, how do I integrate this? Well, I have to rewrite cosine to the 4th in that denominator with its reciprocal identity, so this is really secant to the 4th theta d theta. Well, how do I handle it when it's secant to the 4th? Well, when secant is raised to an even positive power, remember we save a secant squared for our du, and then we convert the rest of these with our Pythagorean identity into tangents. Secant squared becomes tangent squared theta plus 1. Then what we need to do is make a substitution. Since we're already using the letter u, let's go ahead and use a different letter. We're going to use the letter w. We're going to let w equal the tangent of theta. If w is equal to the tangent of theta, then we know that dw is going to equal secant squared theta d theta. We then can write this as the indefinite integral of w squared plus 1 dw. Well, that's something that I can integrate. If I integrate that, I get w cubed over 3 plus w plus c. Getting out of w's and going back into thetas, we know that this is 1/3, and then instead of w, I'm going to write tangent. So tangent of theta cubed plus another tangent of theta plus c. Finally, get out of thetas and go back into x's. Well, how do I do that? To get rid of the tangent, I go back to the triangle. So what is the tangent equal to in terms of right triangle trig? Well, the tangent is equal to opposite over adjacent. So I would say x over the square root of 1 minus x squared plus, again, tangent, which is opposite over adjacent, x over the square root of 1 minus x squared plus c. If I finally clean this up, I'm just looking at x cubed over 3 times 1 minus x squared to the 3 halves plus x over the square root of 1 minus x squared plus c. Number 6, the square root of 25 minus x squared over x dx. What substitution do I need to make here? Well, I have a number minus a variable. When it's a number minus a variable, that's going to be u equals a sine theta. I know that a squared is 25, therefore my a is going to equal 5. U squared is x squared, therefore my u is going to equal x. That means that x is going to equal 5 times the sine of theta. Now I need to write this whole entire integral as an integral in theta. The radical portion, I know that I used the triangle to figure that out, so I'm not there yet, but I can get rid of this x in the denominator because I know that that's going to be just 5 sine theta. And I know how to get rid of the dx. I just take the derivative of 5 sine theta, and dx is going to equal, well, the derivative of the sine is the cosine. Here I write 5 cosine theta d theta. Now let's make that triangle. Well, if x is equal to 5 sine theta, I know that x over 5 is going to equal the sine of theta. If this is my triangle and this is theta, I know that opposite is going to be x, hypotenuse is going to be 5, and that this missing side is going to be the radical 25 minus x squared. Which trig function relates with the Pythagorean identity with sine? We know that that's cosine. So look at the triangle. What is the cosine of theta equal to? Well, the cosine of theta we know is adjacent, the square root of 25 minus x squared, over hypotenuse over 5. If I'm solving for the radical, getting that all by itself, I know that 5 cosine theta is going to equal that square root of 25 minus x squared. Coming over here and getting rid of the radical, so instead of the square root of 25 minus x squared, I write 5 cosine theta. Now clean this up. You have a 5 in the denominator and a 5 in the numerator. Those cancel. And then you're left with another 5. That's a constant multiplier. We're going to pull it out of the integral. So we have 5 times the integral of, well, cosine times cosine is cosine squared theta. And then d theta, and that denominator has the sine of theta. How do I handle cosine squared theta over sine theta? Well, if you go back to section 8.3, we talked about what to do if cosine and sine had an odd positive power. And for even, they were both supposed to be raised to an even power. So I can't use any of the things that I learned in section 8.3. I have to go back and think, okay, how else can I handle this? Well, I know that I could rewrite cosine squared theta with its Pythagorean identity, and that Pythagorean identity we know is 1 minus sine squared theta. Why is that helpful? Because now I can take each term in the numerator and place each term individually over that denominator, and after I do that, I will then have something that I can integrate. How can I rewrite 1 over the sine? Well, 1 over the sine we know is equal to the cosecant of theta. And if I look at sine squared over sine, one of the signs cancel, and I'm just left with the sine of theta. Now I'm basic form. I can integrate cosecant of theta, and I can integrate sine of theta. Therefore, we end up with here 5 times the integral of the cosecant of theta is negative natural log of the absolute value of the cosecant of theta plus the cotangent of theta, and then minus the indefinite integral of the sine of theta is negative cosine of theta, and then plus c. Distributing here first, and we're looking at negative 5 natural log of the absolute value of the cosecant of theta plus the cotangent of theta, and then minus the negative is going to make it a plus, so plus 5 cosine of theta plus c. Finally, get out of thetas and go back into x's. So you're looking at -5, natural log of the out to value. And if you're going to the triangle, cosecant is the reciprocal of the sine. So that's going to be hypotenuse over opposite, plus cotangent is the reciprocal of the tangent. So it's going to be adjacent over opposite, plus 5, and then cosine. Remember, we figured out what cosine was over here. It's that square root of 25 minus x squared over 5, or you can think of it as adjacent over hypotenuse. Well, I can reduce between these 5's, and if I do that, we end up with -5, natural log of the outside value of 5, plus the square root of 25 minus x squared all over x, combining since it has the same denominator, and then plus the square root of 25 minus x squared plus c. Let's look at our last one, number 7. Number 7 is the indefinite integral of x over the square root of x squared minus 6x plus 5 dx. Well, that doesn't look like our quadratic forms. Remember, our quadratic forms that we talked about at the beginning of this section were u squared minus a squared minus u squared, and u squared plus a squared. Well, in order to get this into the correct format, the first thing we're actually going to have to do here is complete the square. So we have to complete the square first. Remember, the first thing that we do is we write it in descending order. It's already in descending order, so x squared minus 6x plus 5. Then we need to make sure that the coefficient of x squared is 1. It is. So we say x squared minus 6x, and then we add a blank, and then we bring over our plus 5. And since we added and we are actually adding a number here, we have to do the opposite, minus blank. Because remember, you have to balance your expression. Then this guy over here is going to factor as something squared. It's x, and then half the coefficient of the linear term. Half of a -6 is a -3. If I take that number and I square it, I get +9. And then 5 minus 9 is -4. That means that I'm really looking at the indefinite integral of x over the square root of x minus 3 squared minus 4 dx. Well, now I look like a quadratic form, and I need to determine which substitution to use. Well, this is a variable minus a number. With a variable minus a number, I needed to use secant. So for this one, I'm going to use u equals a secant of theta. What is u squared? Well, u squared is x minus 3 squared. That means that u is equal to x minus 3. What is a squared? Well, a squared is 4. That means that a is equal to 2. Therefore, we rewrite this as x minus 3 is equal to 2 secant of theta. Now I have to get rid of a lot of things. I need to get rid of the x. So let's solve this guy so I can get rid of the x. If x minus 3 is equal to 2 secant of theta, solving for x would equal 2 secant of theta plus 3. So here I write 2 secant of theta plus 3. Then I need to get rid of my dx. Well, to get rid of the dx, take the derivative of that. What is the derivative of 2 secant of theta plus 3? Well, the derivative of 2 secant of theta is 2 secant theta tangent of theta. The derivative of 3 is 0. We don't need to write that. And then d theta. So here we're going to be multiplying by 2 secant of theta tangent of theta d theta. Finally, I need to get rid of the radical on the bottom. How do I do that? I use the triangle. So let's figure out what that triangle should be. We know that we have x minus 3 equals 2 secant of theta. Solving for the secant of theta, we know that x minus 3 over 2 is going to equal the secant of theta. If I make that triangle, we know that the secant of theta is going to equal hypotenuse over adjacent, which means that that missing side there is going to be the square root of x minus 3 squared minus 4. Now, what do I do to get rid of the square root? Well, I have to ask myself, secant relates to which trig function with its Pythagorean identity? Secant relates to the tangent of theta. So look at your triangle, and from the triangle, what is the tangent equal to? Well, it's going to equal opposite, which is that square root of x minus 3 squared minus 4 over adjacent, so over 2. What does that mean if we're solving for the square root? Well, that 2 tangent of theta is going to equal the square root of x minus 3 squared minus 4. Coming over here, instead of writing our denominator of the square root of x minus 3 squared minus 4, I'm going to write 2 tangent of theta. Now let's reduce. Well, what reduces? I can reduce a 2 and a tangent. Therefore, all I'm left with is the indefinite integral of 2 secant of theta plus 3 times secant of theta d theta. Well, how do I handle this? Well, first I need to distribute that secant of theta. That would give me 2 secant squared theta plus 3 secant of theta d theta. Now I'm basic form because I can integrate secant squared and I can integrate secant of theta. That means that this is going to equal 2. The integral of secant squared theta is tangent of theta plus 3. The integral of the secant of theta is the natural log of the absolute value of the secant of theta plus the tangent of theta plus c. Now get out of thetas and go back into x's. This is going to equal 2. Well, do I know what the tangent of theta is equal to? Yes, going back to the triangle, we know it's opposite over adjacent, or we also found it right here. So we say that this is equal to the square root of x minus 3 squared minus 4 all over 2. And then plus 3 natural log of the absolute value. Well, what is the secant of theta? Well, again, going back to that triangle, it's going to be hypotenuse over adjacent, or we found it right here, and then plus tangent, which we just found, and that's that square root of x minus 3 quantity squared minus 4 all over 2, and then plus c. Cleaning up these 2's right here, we're looking at the square root of x minus 3 squared minus 4 plus 3 natural log, and since I have the same denominator, I'm going to put this all over 2, and that's x minus 3 plus the square root of x minus 3 squared minus 4 plus c. Now you can leave your answer like that, but I just want to let you know that the book will go back to the original trinomial. So instead of writing this square root of x minus 3 squared minus 4, it's going to go back to the one that we had originally, and that one is this guy right here, x squared minus 6x plus 5. So you're going to see the book answer this as the square root of x squared minus 6x plus 5 plus 3 natural log of the absolute value of x minus 3 plus the square root of x squared minus 6x plus 5 all over 2 plus c. That's it for trigonometric substitutions.